So an algebraic expression is a relationship or a rule that links different variables. Okay, that's what it is. We're talking about generalized arithmetic or a rule. Okay, for example, the area of a triangle is half the base b times h, which is the height, half bh. Okay, that's a general expression for all triangles. Right? But the thing about substitution is, instead of just leaving it as a relationship between variables, we say, well, let's find out what the value of this expression is if we substitute in values for those variables. Okay, so basically what you're doing, instead of writing letters or using those symbols, we're going to substitute in using numbers. Okay, so in the case of a triangle, you actually want to say, well, I want to find out the area of the triangle that has base 4 and height 2. Okay, so instead of b, you're going to write 4. Instead of h, you write 2. That's the basic thing, and this is called substitution. That's what it is. All right. So that's what substitution is. Now, this is another example. A rectangle has an area of A equals LB, which is the length times breadth. That's always true for any rectangle. All right, so that's like an algebraic expression. It's a relationship between two things. A, which is the area, and L, which is the length and breadth. There's a key and there's a set relationship between those things. There's a rule that links these variables. But of course, I don't just want to know generally about rectangles. I may want to know a particular size rectangle. What if a rectangle has length of 3 and breadth of 5? And so that's when I need to find out. So I'm just going to close this off, restart it. Okay, so that's when I need to know these things. So if A, what is A if L equals 3 and B equals 5? Well, I can say, well, A equals LB. Now, L is 3. My writing is getting worse. Times B, which is 5. Right? And 3 times 5 is 15. Okay, so it's 15. Right? And essentially, that's what this is for substitution. All you're doing is you're given a relationship, an algebraic expression with variables of x, y, a, b, whatever they represent. And then you said, well, in this particular case, where a equals 5, b equals 6, and c equals 7.5, what is the value of this expression? Okay, that's what you're asked to find. And this is a very important thing. This is sort of one of the points of algebra and this sort of maths, is that when you have a general rule, then you need to find in all sorts of fields, whether in economics, looking at the way money works, looking at the way cars are built, or in engineering, all these sort of things. You have a general rule about how something is linked, but then you have to find out for a particular case, with a particular set of values, how do you find that value? And that's what we do. We do substitution. All right, so that's what we're going to do. Let me just align this, see if it actually works. And because I've asked somebody to look at this, but it has not been looked at, I assume. Okay, so I'm going to have a look at a few examples, and then we'll get into some more. All right, so if we have a look here, examples, if x equals 4, y equals 6, Chelsea, and z equals 4.5, find the value of the following expressions. So we're going to use the same values, x equals 4, y equals 6, and z equals 4.5 for the next few examples. Okay? Right, so the first one is x squared plus y plus z. Alright, so what we do is we substitute in the values. So we say, well, x is 4, so instead of writing x like in the expression, we say, we use the substitute in the number, which is 4. Alright, so we say 4 squared. We do exactly the same thing to 4 as we did to x, because in this case we're saying 4 instead of x. Because it's given to me in the question. X is equal to 4. Okay? And then I say plus y is equal to 6, so I'm going to put in just y, so that's 6, and z is equal to 4.5, so I do plus 4.5. Right. And so if I work that out, that's 16 plus 6 is 22, 22 plus 4.5 is?
26.5.
Good, 26.5. Okay, so 26.5. So what this means is for these particular values, this expression has a value of 26.5. Alright, that's what this means. Are there any questions so far? No? Okay. Sounding familiar? Yeah. Let's go to the top here. Okay. Now the next one is 3z minus 2y. So what it's saying is multiply z by 3 and then take away 2 lots of y. So this would equal, instead of writing z, we have to write 3 times. What is z in this case? 4.5. Substitute it in. 4.5. And then we take away 2 times what? 6, because y is 6. So 3 times 4.5 is what? 13.5 minus 12, and the answer is exactly 1.5. Okay, so again, you take a given, what the value is, and then you substitute it into the expression. Agree? Okay, so that's the way that we work this. If it says z, you substitute the value in. If it says y, you substitute that value in. And then you have to do order of operations, make sure it's all correct, and then you can work out what the solution is. Okay? I'll do the next one. Zx over 2 minus y squared. Okay? So we're going to go here. Zx over 2 minus y squared. Okay, good. So let's do, so it's 4.5 times 4 over 2, okay, minus what? Yeah, so 6 squared. Good. So I'll just write 6 squared for the moment. All right. So 4.5 times 4 over 2 minus 6 squared. What's 4.5 times 4? 18. So we've got 18 over 2 minus 36. What's 18 over 2? 9. And then what's 9 minus 36? Negative 27. All right? So we end up with minus 27. 27, negative 27. The same. Okay? Any questions? Right, so you substitute the value in. The last one, I think, is one more that we could do. There's one more. X plus y plus z over 2. Right, so this one equals x plus y plus z. So x is what? 4. So it's 4 plus 6 plus 4.5. So we're finishing this now. Over 2. Okay, so that's 4 plus 6 is 10. Plus 4.5. Chelsea Lachlan, can you swap seats, please? Ainsley shift over, thank you. 4 plus 6 is 10. Plus 4.5 is 14.5. So that's 14.5 over 2. It is. 7.25. Okay, so those are the examples. You're taking the value that you're given and then you substitute it in instead of that variable. And then you work out and do the calculations. Alright, so exercise 2.05. I'll put up the